Welcome. I'm Homer Kraut, and we're going to spend a few minutes today talking about practical quality. It is cheaper to do it right the first time than to have to do it over. In general, quality is in the eye of the customer. All of you have had varying degrees of experiences in purchasing items as a customer. As a product manager, even if you build or what you consider a quality product, there is no guarantee that your customer will have the same perspective or view. Too often we hurry a product towards completion and then have to spend resources to correct issues with the product or to redo it. There are a number of reasons for this. Some are very valid, some based on practical considerations, some based on a need to rapidly produce a product, but in the end, if you have to do it over, it's going to cost you more. What we are going to cover in this session, WCB versus ISO. WCB stands for World Class Business. ISO is the International Standards Organization. Customer complaints is a data source. We will look at diagrams and data. We will look at process control and spend a few minutes talking about each of these. As noted earlier, WCB is a world-class business. ISO is an international standards organization, and all of these items contribute to an overall practical quality of a product or an item that you're developing. In general, practical quality is defined as standards for which a product was developed, which meets a customer's needs and expectations. Please note that I talk about a customer's needs and expectations and not yours. You can develop all you'd like, you can meet any standard that exists, and if a customer does not purchase or like the item that you've developed, you've failed to do what you need to do, and you'll probably lose money. WCB versus ISO. Again, World Business Class, International Standards Organization. There is at least one other term here that you should consider, and that is ABC. That's the Applied Benchmarking for Competitiveness. There are a number of standards organizations, and most of you are familiar with a lot of them. As you develop a product over time, you need to review the standards for similar products. You need to ensure that your product meets those minimum standards that are put out. And in general, you should try to meet standards that exist today rather than trying to chase emerging standards. Too many times, particularly in the field of technology, we spend an inordinate amount of time chasing standards that are ever changing. New standards always change, and your best bet if you're trying to develop a product for which you're going to be spending money or earning money, then you should meet some standards that have already been developed. In the short term, you should select a course that best suits your needs with ABC, that's Applied Benchmarking for Competitiveness, for a base if possible. In the long term, you need to move towards ISO using ABC for better long-term results. Again, International Standards Organization and Applied Benchmarking for Competitiveness. This lesson will not spend a lot of detail on any of these three areas. As you begin to develop a product, you need to research and study and learn more about these concepts in detail. What we are going to do is to prevent a very brief digest or distillation of these subjects in a short amount of time. The International Standards Organization generally develops standards for a variety of fields and products. There are other standards and other standard organizations. The company that you work for, the country that you're located in may have another set or their own set of standards. In general, standards meet ISO basic standards, and then add standards as needed for their particular product, their particular organization, or other requirements that they may have. Some items that you're familiar with that already meet standards are quality of water, fuel standards. Most of us are familiar with fuel standards. When you go into a petrol station and you buy fuel, you generally find fuel within a very narrow set of standards. Clothing standards. Most clothing is sized, and it's based on a set of international standards, so that if you buy a small, it falls within a very narrow range of sizes. Material standards. When you buy bolts, nuts, other types of supplies, and you order a widget that meets very specific standards, it should meet the same standards whether you order it from company A, company B, or company C. As we develop practical quality, you need to resolve all issues as close to the source of a problem as practical. This is essentially the essence of practical quality. Problems tend to be compounding. A problem that occurs early in the development process or in the development of a product tends to compound if it's not corrected and identified and time spent in correcting it early on. Practical quality is a core concept. This is particularly true in data collection. As you collect data, and if you're transmitting that or translating that data into information, the further you get away from the original data and the data source, the worse the errors will be, and they tend to be compounding. But this also applies to process production. If an error occurs early in process or production and it's not caught, it compounds it, and the cost to recover from that become compounding also. It's practical in a sense that you need to catch errors early on and change them where it's possible. Customer complaints. We live in a customer-centric world. What you have to do is to strike a balance between what you are delivering and what the customer perceives as what they need and the quality of that delivered item. The best you can do is to deliver a product that meets the requirements that have been outlined for you. The customer will decide whether it's good or bad and whether they purchase it or not. Your products should be based on detailed requirements. You need to understand what a product was designed to do in order to resolve issues or complaints with it. When a customer complains about a product, you should view it from both a positive and a negative aspect. What is good about the complaint? What is bad about the complaint? I will note that any time that you respond to a customer, your response has to be timely and it needs to be positive. And as much as possible, you need to resolve the issue in the customer's favor. Okay, customer complaints is a data source. We need to look at the overall level, the cause of the complaint, types of the complaint, and collect information about each of these areas. You need to begin collecting customer information as soon as possible. A good example of this is Google. They generally collect every single mouse click and every single item of information as input as you move into and through web pages that come from their site. They use this data to personalize your Google experience. They are collecting information about your habits, about your buying habits, about your browsing habits, and as much as they can about, so that the next time when you move back into Google, they present a web page to you that has been individualized for your needs and your preferences. I'm a woodworker. When I go into Google, most of my selections are based on my processes or things that I need in the woodworking field. When I go back to Google the second time, they provide me with things that I am more likely to purchase, to look at, or to move through in terms of web pages. On the back end of Google, businesses pay Google to move me in their direction. They are collecting data on me as a customer. It helps to have statistical data collected over time. If you only collect 1 or 2 items of data about customers and customer complaints, then you really do not have a foundation on which to resolve anything. And when I talk about collecting customer data, you should attempt to collect both good data and bad data. Good data in the sense of when customers make positive comments, which they don't do very often, but when customers make positive comments, you should collect that data. When they make negative comments, which they do more often, you should collect that data also. The more facts that you collect, the better you able are to make an informed decision and respond to the customer. Some of the questions that you must ask yourself. How many complaints are there? If you only have 2 complaints and you have thousands of people buying your product, is it a valid complaint? It should be answered, but it's not as important as if you have 1,000 buyers and 500 complaints. That's 50% people complaining that purchased your product, complaining about the product itself. You need to collect data as to what the complaints are about. Are all the complaints the same? Are they different? Are they in different areas? Do they come from different people, levels, ages, backgrounds? That's the kind of data that you need to collect. Is the data collected based on fact? A lot of times people will say, well, that's not very good. Well, why is it very good? Well, I don't like it. Neither of those statements are based on data or facts. When you receive customer complaints, the best you can do is to collect as many facts about an issue as that you can. You need to determine what is at the core of the complaint or a complaint. How do you determine if a complaint is valid? That's very difficult. What I may complain about in terms of a product and what you may complain about are certainly or could certainly be 2 different things. So when you look at an issue or you look at a complaint, the best you can do is collect as much data as you can, attempt to resolve a customer's complaint, and then use that data to resolve issues about your product or about additional customer complaints. You must address customer complaints in a timely and a positive manner. If you don't, they won't come back, and in today's web-centric world, the word will very quickly spread that your product is not satisfying a customer's needs. Diagrams and data. Unfortunately, the age of technology and computerization has moved us away from visual data on walls. Technology does allow us to collect more data in a timely fashion, make better use of that data, give her a better way to analyze data and provide information from that. But unfortunately, it tends to stay on a computer. If data or information resides on a computer with no distribution, we lose sight of the information that could be available to us. Visible data reassures employees. They can see how the company's doing. It may show that they're not going to go under next week. It keeps everyone informed, and it represents a confident face to the company. You can look at data or diagrams on a wall and you can say, oh, the company is doing very well. A good example of this are the stock market reports. Very quickly, as you peruse or the news comes on with stock market reports, you can very quickly see whether a company is doing well, doing bad, and how they look over time. A caution here is that you should read most stock reports very carefully. They generally tend to, on the bottom line, if you will, on the x-axis, they tend to put time, in generally months or years in some cases. Look very carefully to the y-axis, which is generally on the left side, and see what the scale is. If they show a deep dip in product sales, look to the left and see if they've spread a large distance between a 1 and a 2 and maybe a 1 and a 10. Again, diagrams and data. We're going to take a look at some examples of these. We have flow charts and process and physical flow charts, and these are both part of primary tools. We have check sheets. We have Pareto charts. We have run charts. Now I'm going to move to a second slide and come back to this. Some secondary tools are histograms, control charts, and process capability charts or reports. And now let's go back. All of us have seen flow charts. Take a look at a stock market report. That's a flow chart. We generally establish flow charts to provide general outlines of a process or a product. Check sheets. Check sheets are just that. And most of us are familiar with check sheets. Most of us have a to-do list, a grocery list, a list of things that our wives or our spouses have given us to do, and those are all check sheets. We have an item, and as we complete an item, we cross it off or check through it. These are very typical in maintenance types of issues. If you're maintaining machinery, forklifts, vehicles, you have a list of things that must be done on a daily, a monthly, a yearly, and even a 10-year basis. And as the time occurs, you move through this and you very carefully check each item and then check it off of the checklist. It's a very, very common item. Pareto charts. Pareto charts were developed by an Italian. They contain both bars and a line graph, and they generally represent multiple sets of related data, and they generally portray cumulative data. I'll show you an example of a Pareto chart in a bit. Run charts generally display observed data in a timed sequence. This type of chart is often used in a place that has continuous production, maybe a newspaper or a magazine printing type of office. This would include things like uptime, downtime, runtime, percentage of maintenance time, percentages of time that it's been up for or down for lack of a product, or up for. So these would be expressed in percentages over time. Okay, back to our secondary tools. Histograms. Histograms are generally a graphic representation of visual data. The data is generally historical in nature. I need to point out at this point that there are two types of information that you can get from data that you collect. The first is descriptive. Essentially what you're doing is taking data that you've collected and you're describing it in a historical sense. Greater than, less than, what happened in March, what happened in May, what happened in June. The other type of information that you can get from data is inferential data. I can look at my production or production of a product for the last year and predict how well I am going to produce, sell, or what it will cost to produce the product for the next year. That's inferential data. In general, what we're talking about in this particular lesson is descriptive data. We are looking at data that has been collected and we describe it. If we look back mentally very quickly to customer complaints, we could take historical data and compile historical data from customer complaints and use that to infer or predict how many complaints we'll have over the next year. Back to histograms. Histograms give us a visual representation of data. Control charts. These are generally after-the-fact charts. They are statistical in nature and attempt to show the statistical nature of a process. E.g., a machine that produces widgets is available or has been operational 90% of the time. That's the kind of information that you would find in a control chart. Process capability is generally a diagrammatic chart that shows the overall capability as well as the actual capability of a process. It's similar to a run chart, but it looks at a process from the whole rather from the individual parts. Okay, I'm going to give you some examples at this point. Process flow chart is the first example. We have an input, we have a decision point, we have a process, and then we have an output. This is very, very simplistic. However, it has lots of application in the business world. In general, when you see a chart like this, it's complex. There are generally more than one input point. There is generally lots of decision points. Now, a decision point can do a number of things. In this particular case, there is some input. It's looked at or evaluated by part of the process. A decision is made about whether the input is acceptable or not. If it's not acceptable, it goes back to the input. If it is acceptable, it's passed on to processing, it's processed and goes into an output. We could have a number of decision points in this, and in a few minutes you'll see a chart that shows the same type of process in a little bit different format. These generally have multiple control points, multiple evaluation points, multiple checkpoints. It's a very common design, can be expanded. It represents a good summary view. You can look at this on a wall or on a wall chart or even on a computer screen and see very quickly what you're trying to do and what the general types of processes a product or a raw product will go through. It's easy to see and interpret it. Very, very seldom do you need to call in an expert or somebody to explain this to you. This is a process flow chart. Take a look at it real quick. We are manufacturing something. It's inspected. There's a decision made here. It either goes on to finishing, it goes through to be reworked, inspected again, it may go on to finishing. Once it's gone to, if it's not, or if it fails twice, it may go into a scrap bin. If it's passed to finishing, goes into finishing, it's inspected again, and it's moved into a good part bin. This can be also interpreted as a run chart. This depicts information from collected data. This kind of a chart will provide you with an extensive amount of information. You can look at the quality of the input product or the raw materials. You can look at the quality of the output or what comes out of this. You can look at an item and determine why it was put in the scrap bin. If all of the items that go to the scrap bin were put there for the same reason, it may be a part of the process is flawed. If they have multiple reasons, then you have a different issue. But evaluating or looking at items that go into a scrap bin is critical. You can look at the rejection reports. Why is an item rejected here to go to rework? It's the same issue that you had in the scrap bin. Was it rejected because of one item? Is it a single machine in the process that is turning out bad parts? Is maybe a stamp mill being off? So you look at this and you say, why is it being rejected? Then you can look at how it's being reworked. Goes back to inspection and whether it passes or failed. And it goes back into the finishing. This kind of chart can give you an overall capability report. What is the capability of your process? Are you getting 100% return on your raw materials? Are you getting 20% return on your raw materials? Do you expect to get 100% return on your raw materials? This kind of chart will assist you in making that type of determination. You can get run reports out of this. Did a product go through correctly? How often was the machine up? You can get a process report. Did all of the processes function 100% of the time? Or did one process only function 40% of the time and another process function 90% of the time? The other thing that you can do is to say, what process was being worked harder? And it may be that those processes are being worked harder. If a process is being worked 90% of the time in the whole process, and one item is only being worked 40% of the time, maybe there needs to be a redistribution of the effort for the whole process. You can get histograms out of this. You can look at this and look at the quality of data over time. You can look at the quality of the scrap over time, why things were scrapped. You can look at a histogram of inspections, a histogram of output. You can even look at whether an inspector, you may have one inspector that passes 100% of the items and another inspector that passes 50% of the items. Why are they doing that? It's hard to tell, but at least you have data on those individuals and you can tell why and where that they're collecting data and why they're turning it back. This kind of a chart provides you with a lot of information. Collection basics and check sheets. You need to define what is being recorded. You need to define over what time period. You need to make it easy to record the data. You need to ensure that the data is recorded honestly. Make absolutely sure that data that you collect is honest and correct. Establish a means to simplify and display data as information. In general, when we talk about charts, runtime charts, histograms, we're talking about taking data and displaying it in a format that you can use. And again, data is based on fact that you collect, and information is what you do or gain from that data. Information report examples. We have measles diagrams. We have histograms, control charts, run charts, scrap rejection reports, and output charts. What I'm going to do, we've talked about these in some detail, and what I'm going to do very quickly is to run through and show you some of these charts and talk about them briefly. A measles diagram. Why is it called a measles diagram? Because it's busy. It shows you a lot of information in a short period of time about a lot of a process. Material comes in, it goes through a main drum, we have a tape dispenser, a knife cutting system we would assume, some sort of a transfer wheel and a packer. Based on what we've already talked about, you can collect lots of information about this particular diagram. But in particular, how would you collect information about the main vacuum drum? We would assume that there's some sort of a negative pressure in that you need to monitor, maintain, and or collect. Histograms, as noted before, it's a summary of data collected over time. In this particular case, you can see that we collected data and that in some cases we've met a target, some cases we've reached a target, and in some cases we've exceeded a target. The kind of information, again, historical data. Control charts. Again, a control chart just allows you to very briefly look at statistical information about the output of a process and the end product. A question that you might ask yourself at this point is, how do we ensure that this data is correct? Run charts. Run charts display data in a time sequence. In the case we're shown here, we're showing that collected data shows a product in an average point, and it also meets some upper control limit and some lower control limit, or at least falls within those parameters. If I'd put some numbers off to the left and the right, you'd probably have a little better idea of what those meant. But in general, this is what a run chart does. Scrap rejection report. All we're doing is looking at this and determining what was found at fault, where it is, and how many of them there are. There are other things that you can gain from this. You can look at why a product was flawed, when it was flawed in the process, and maybe what you need to do to correct it. One of the questions that you should be asking yourself is, why is this type of report important? Are there acceptable limits to this type of report? If this were so far out of range, you might have a major issue, and it may be that you're wasting materials or have a flawed process. Output chart. This is very common. As I look at this chart, though, it does tend to tell me some information. In general, I would assume that this is based on an 8-hour day, and I would assume that the job is performed during daylight. I would assume that it takes some time to ramp up in the morning. I would assume that there's a mid-morning coffee break, maybe a late morning coffee break. There's a lunch break. There's a mid-afternoon coffee break. And then I would assume that the line that takes us down to where it stops is an end-of-afternoon product downtime. It's an interesting chart, and it provides lots of good information. In summary, the chart summary, charts provide a quick way to see results, a production and output summary, a quality predictor, and they allow you to manage and maintain a good look at your processes. Let's take a look at waste elimination. We generally use the same tools for waste elimination: pre-production quality reports, in-process quality records, and sample analyses reports. We generally try to maintain a low level of waste. If you have a high level of waste, then you may be misusing raw materials. In some industries, the use of waste constitutes an additional profit. For example, in the newspaper industry, as you create and develop paper for print, there is an output product that is used for silage and fillage for landfill. And it is cost effective to sell that to someone and add it to your profit line. In terms of process analysis, the issue is keeping accurate records, inputs, and information about process and outputs. You need to manage your system for efficiency. You need to ensure quality at each level of your process analysis. Ensure that your product meets the requirements. And overall, ensure that what you're developing and what you're designing meets the needs and requirements of both you and your customer. Most importantly, does it meet the needs of the end customer? And have you met customers' needs in terms of quality and in terms of satisfaction? In summary, you need to achieve and maintain the quality of your product. And there are a number of ways to do this. You need to develop a process based on requirements that creates a product that meets both quality and needs standards. You need to manage production so that you have kept costs down and that you can gain enough profit to meet your costs. You need to use customer complaints as a data source. Please do not blow off or to complain about what customers say. They are the individual or the end process or the end product of what you're trying to do. You must meet your customers' needs over time. In order to manage, maintain, and look at what you're doing, you need to maintain diagrams and data. You need to collect the data, and in general, you should probably collect data in an electronic format, computer-based, if you will. You should display your data in reports, both on a computer and in a fashion that can be seen by those people that need to see it: customers, employees, and management. You need to maintain and develop process control. You need to make sure that what you're developing meets end product needs, end customer needs, and does not run over budget. Some questions that we've talked about during the lecture. What type of data needs to be collected? What type of output displays, reports, and information do you need to provide so that you can manage and control your processes and your product? What type of display or output best suits your needs? Electronic, paper-based, or wall charts? This has been a quick look at practical quality. If you have additional questions or need additional information, please visit the university website.